Board, share screen, righty thing. Oh yeah. Oh wait, I gotta pause. Sorry, pause. Right. So yeah, so today is the 26th. I don't know that anyone ever actually cares when they watch the videos what the date is, but it's something I do anyway. So today's the 26th. The year is 23. And this is just stuff to go with assignment number 32. Today, you'll also be doing a snapshot, just for the record. I know I've been just murdering you with snapshots, and I'm sorry, but this one has one factoring problem, one quadratic formula, one square roots, and one completing the square. So it's just a little sample of each. But step one is I got to get this out of the way so that when you get to work on this assignment, because for some of you that's going to be soon, some of you it won't be till later. I don't even know, but I want to make sure that you're prepared for this. So problem number one has us doing 4k squared plus 8k minus 71. And this fits nicely with what you did on Delta Math. None of the worksheet problems that I gave you yesterday on assignment 31 had this characteristic, but on Delta, you'll recall that some of them had numbers in front of the x squared or the m squared or whatever. So what do we do first? You honestly, you could add the 71. I would take that as a first answer, and I would also accept dividing everything by 4, or you can just save time and do them both at the same time. But kind of knowing where we're headed with this, we know we have to first off kill this 4, and the only way to kill that 4 is to divide everything. Remember, you can't pick and choose who you divide. You got to divide the whole shooting thing, whole shooting match by 4. So if I divide everybody by 4, I wind up with k squared and plus 2k, and then I'm going to leave an awkward space, and I'm going to move that 71 to the other side. But this was why people raise their hands very, very quickly, is that for the first time now, you see that the number, the C value, cannot be divided by the thing that we're dividing by. So that's why we're having this little mini lesson here today. So yeah. So anyways, when you move the 71 over and it becomes positive 71, and then you divide it by 4, you get 71/4. So let's just pause there for a minute and make sure everybody's okay. What happens with the C is not important to me. What happens, well, the only thing I'm interested in is that I got the k squared by itself, and anything else is just collateral damage at this point. So it's time to start the algorithm now. Remember, the steps, once you get them stuck, they just really tend to not go very far. It's very simple. The next part of this process is to take the number that I'm circling and take exactly half of it. And half of a +2 is exactly a +1. And I'm telling you, you should write that down, and I'll show you why here in just a moment. Don't forget, writing that down will help you. Now take that purple number that I wrote and square it. What do you get? You get 1. So the magic number that I'm going to use to complete the square is a +1 and a +1 like this. There's absolutely nothing new yet. So if you're looking at the board like already lost, it's got to be because you haven't been here. Like I haven't done anything special yet. It's all the same steps. I'm going to factor the left-hand side. And I sometimes hear people say that this is the part that I, quote, suck at or struggle with. And all I can tell you is you don't even have to know how to factor. I'm sure I said this yesterday and I'll say it again. You don't even have to know how to factor. When you break down this left-hand side, you can just put your k here and then remember this number up here that we wrote down earlier. We just take it, copy it in, and presto. You just factored without even knowing how to factor. This is where the new part starts because this hasn't happened to us yet with completing the square. What's the problem with the right-hand side? One's a fraction and one's not. And so we've been down this road before, and we know the solution to that dilemma is to turn the one that's not into a fraction. So I'm going to take the whole number 1 and ask myself, how could I turn you into a fraction? I could make it 4/4. I can make it anything I want. He's a mathematical chameleon. If you wanted him to be 9/9, he's like, I got you. Like you can be whatever you want as long as it still equals 1. We select 4/4 because we want it to match with the guy to his left. So I'm going to take the +1 and I'm going to swap it out with 4/4. And now I'm going to add the numbers on the right-hand side together because, well, that's what we do. 71/4 plus 4/4 makes 75/4. So the next thing we're going to do in the algorithm, the process is it's always the same. We're going to take the square root of both sides. When I square root the left-hand side over here, what do I get? Okay, plus 1. And when I square root the right side over here, thank you for saying that, by the way. I'm just impressed. It is the square root of 75, but the square root of 4 is 2. So far, so good? Now, the trouble with this is, well, we got a long ways to go, but the square root of 75 is not a dead root. So if I go off to the side and write that down, I can make a tree, a productive tree. Not like 30. 30, you can do a bunch of things, but none of them matter. 75, how do you bust them up? Yeah, it's the only sensible thing you could have said there. Thank you for that. 25 and 3. 3 quarters make 75 cents. And don't say stuff like 75 times 1. That's bad. And what is the square root of 25? 5, not 5 and 5, just 5. So the answer to this is 5 root 3. So what I'm going to do now is I'm going to take that root 75 up on top, and I'm just, as always, going to swap it out with the better version of it. We okay? Zach, are you good? Everybody good? Okay. Now, again, back to, we kind of sometimes have to leave the land of what we're doing to go do annoying stuff, like change denominators and simplify radicals and stuff. But now we're back to the algorithm, the process. What's the last, well, next thing we have to do? Yeah, you got to get the 1 to the other side, right? If we're trying to solve for k, then that's, of course, what we do. So the next step in the process is we take this number 1 and we remember move it right there. Right. And I want you to watch what I'm about to do. Sometimes I try to talk. It's hard sometimes to speak one thing and write something else. You should try it sometime, but here it goes. I'm going to say k equals -1 plus or minus 5 root 3 over 2. Right. And again, I use this expression even not as a rodeo guy. This ain't our first rodeo. Like, you understand that here you go again with a whole number and a fraction. You might as well just make the whole number into a fraction while you're there. Now what I'm going to do is I'm going to take these things that I'm putting in this funny purple shape, and I'm going to just basically add them together. And not, I don't mean like actually get an answer, but I mean express them as one problems. Because if I made the bottoms the same, I might as well put the tops together. So I have k equals on top -2 plus or minus 5 root 3 all over 2. So this is an interesting problem in that we're done. And a lot of times people would say, like, well, what about the Dorito? And my answer is, go ahead, draw the Dorito if you want. But when you look at your triangle in this case, I don't mean to ask rhetorical questions, but what can you divide those all by? Nothing, right, other than 1. And so in that case, the Dorito, the division doesn't work. Someone asked earlier, well, can't you reduce the 2's? No, the whole point of the Dorito is to remind you that this exists in a 3-pack or none at all. Like, we're all 3 going to the movies or we're all staying home. Like, you don't get to selectively pick a part of it out, reduce it, and leave the other part alone. So me drawing that triangle isn't just because I like to say like Dorito. It's because I want you to understand that those numbers in that triangle are a team. And if they all don't divide, then nobody does. Got it? Okay. I want to do problem 2 with you. And honestly, I don't even really know why, but I think it's a consistency thing. We did this one first hour, and so anyways, what's step 1?
6.
Yeah, and again, I would take either answer, or my preferred answer is let's just do them both. We got to kick the 6 to the other side. We also have to divide away the 2. So let's just do it all at once. So if I take that equation and I divide everybody by 2, I'm going to wind up with just regular a squared plus just 2a, an awkward empty space, and equals +3. So I guess I wanted to do this. Maybe my inspiration earlier was that, like, I just wanted you to see that not every problem on the worksheet is going to involve fractions. This should totally have you now back in your comfort zone. Just like, oh, I just did 30 of these in the last couple of days. I got this. So we begin the algorithm. No fractions, no denominators, easy peasy. What is half of +2? Plus 1. And I keep saying that in hopes that you'll write down the plus with the 1 or the minus with the whatever, because again, that sign here in the next step is going to come down with the number when we do the factoring step. Expressing if he's a plus or a minus feels important to me. What's plus 1 if you square it? So once again, I find myself adding 1 to both sides. Do you see it already? Is this a pathway problem or not? It is. It will be a trace the pathways and give me 2 rational answers because I see it coming down the pike. 3 plus 1 is 4, and 4 when square rooted is normal. So we're good to go. Let's do this. The left side, I put the parentheses squared. I drop my variable in, and again, I grab the number that I wrote and I move it in, and yay, I just factored. On the right side, I just have to do a little 3rd grade math. 3 plus 1 is 4. And now it's time to square root both sides. What do I get on the left?
8 plus 1.
2. Yeah, square root the 4 to get 2. And now you see it's going to be a pathway because when I move the 1 over, I have parts and pieces that can go together. And the expectation in math land is that if you can go further, go further. And so I'm going to wind up with a equals -1 plus or minus 2, but those are both things that I can answer, so I do. If I take the top path, the plus, what's -1 plus 2? So one of my answers is 1. If I take the bottom path, what's -1 minus 2? And those are my answers. The next one I think I want to do with you is, I think that's 4 was the one that I did. And then after that, I think I'll probably generally get out of your way and I'll let you do your snapshot first and then work on whatever you need to work on today. So but this one has some real trickery about it. It looks so innocent and harmless, but there's a little funk. What do we do first? So again, this is number 4. Say it again. Sure, let's divide by 3.
You don't have his.
Well, you actually could, but I feel like maybe we should move that 5 to the other side first. Are you guys okay with that? That 5, that -5 is calling to you. Would you please send me over with my homie so that we can add together and just make one number? So why don't we not divide in the first step? Why don't we just leave it as 3x squared minus 6x, awkward void, equals, what's -7 plus 5? -2. Good so far? Now we divide by 3. And things get a little interesting. So when I divide by 3, I get x squared minus 2x, and I'm not concerned with that. It's this funk on the other side. What do I get? It is. I feel bad for you guys who really, really struggle with the fractions. And while I know it's not my fault that you struggle with fractions, I still feel bad because I know it's got to be frustrating. Next step is to do the algorithm. Half of -2 is -1. And when you square a -1, what do you get? You get a +1. So I'm going to add 1 to both sides. I mean, you almost feel like a robot. You do a dozen of these, you just literally start to feel like a robot, just performing a set of programmed steps. On the left side, I put my parentheses and my squared, drop an x in, and what do I put after the x? Yeah, that number just goes zoop. Some people still don't write it down, and then they go, I don't get that part. And I'm always like, man, you should write that down. Okay.
So it's not the one.
It's always half of the one I'm pointing at with these purple arrows. Yep, that will always go there. Right side, we got that little grade school dilemma thing. Here we go again. So when I said +1, what really should I have written? I should have named him 3/3 right from the get-go to make him compatible. And what's -2/3 plus 3/3? 1/3. And if you stopped listening because you're like, I don't know why he's still talking, I get it. You really should perk back up. This part, I just kind of freestyled this morning and came up with a new way to do this. And I was like super stoked because I think it makes perfect sense. The trouble with what we're about to do is we're about to take the square root of both sides. And you probably don't know this yet, but in math, you'll learn this as you go through more math classes. You're not allowed to leave square roots in the bottoms of fractions. You know how math just has its own set of stupid rules? That's one of them. And so if you see what's about to happen, if I square root the right-hand side, I can square root the top to get 1. I don't care about the top. But on the bottom, I can't take the square root of 3. So what I want you to do is help me. Have you ever unreduced a fraction? You can. We're used to taking fractions that have numbers like 5 and 15, and we divide them to make a smaller looking fraction, right? Can you help me unreduce the fraction 1/3 so that the number on the bottom is square rootable? Becker? You could. Someone earlier today said 2/6, and I thought, I'm proud of you because that is a good unreducing, but it's not the one we want because can I square root the 6 on the bottom? No. So you've got the right idea when you say 2/6, but it's not arbitrary. When you said 3/9 and you said, can I multiply by 3? The answer is yeah. What I want to do is I want to buff the fraction up to the point where I can look at it and say, hey, if I multiplied your tops and bottoms both by 3, then you become 3/9. You still equal 1/3, but now I like you better because your bottom is square rootable. So for the first time ever, you just unreduced a fraction. There you go. So what I'm going to do now is I'm going to swap out the 1/3 and I'm going to bring up in his stead, I'm going to bring the unreduced version of him. And again, the reason for that is because now I can square root and I won't get a square root on the bottom because I don't want to teach you the lesson today on how to fix square roots when they're in the bottoms of fractions. So that's a workaround. Simple pimple. All right, so let's square root both sides. If I square root the left-hand side, what do I get? And then I put equals, positive, negative. And if I square root this right side, what do I get?
Plus minus. Plus
Root 3 over 3. The square root of 3 on top just has to stay as the square root of 3, but the square root of 9 on bottom, we set it up so that we get a whole number. Now what? We add the 1, so I'm going to write x equals 1 plus or minus root 3 over 3. Then what? Combine it, 3 plus or minus root 3 over 3. And then what? Nothing. We're done because, for Kennedy, there is no Dorito that can help us here. Earlier, someone said, well, they're all 3s. And my answer is, don't you dare. The number in the root is off limits. The numbers in my triangle are 3, 1, and 3. Remember, it's everybody or nobody. And so we are done at that point in time. Got it?